Very good afternoon. Myself, Dr. Ravi Kumar Poluru. Today's topic is model-based software architecture, a technical perspective. So last class we have discussed a management perspective regarding the software architecture. So in the management perspective, how the software architecture can be made by the expert teams. So they have discussed that there should be a strong team. So if one of any member is not commit with the other member, then the project will be failure. Okay, so that's why they will take all the aspects to recover and to gain the success for the project. So today we will see how the technical perspective will be there for the software architecture. Okay, for the software architecture, so we know that mainly it will be consisting of structure. Okay, structure of the software system, and there we need to select the different types of the elements, or we can call as the components, and these elements has to be checked that whether this is small or big. If it is a larger, then we need to subdivide it into a subsystems of the components. Okay, so if the component is a very larger, then we need to divide into a smaller, or we can call it the subsystems, and we need to verify that behavior is very important, because the behavior is will tell that how the information or the relationship among the elements. And next one is patterns. These patterns will tell that how the informations or the elements will have the flow of the information between from one component to the another components. Okay, so mainly here the software structure can be defined in many ways. Mainly they're going to check that components have the structure, and they will check the behavior and the patterns. This can be when they're going to verify these constraints or the metrics, they need to check that the functionality, how this architecture of the components will be performing, and they're going to check that the performance. So performance should not be degraded when they included the components in the software architecture. And also resilience. Resilience is nothing but if any fault tolerance is occurred, or the error will be occurred with that execution of the components. So they need to rectify the problem and have the alternate way of transferring the information from one component to the another component, and have the comprehensibility, and to check the economic trade-offs. So while they're designing the architecture, they need to check that what is the economic scaling or the scale. So mainly they need to concentrate upon the scale, economic of scale. And also they need to check that the technology constraints. So what is the main constraints when they're using the using for the components, and how this will be impacted to the project. And also aesthetic concerns. Is there any difficulties during the building of the software architecture? Okay, so here the architecture framework. So we can define that architecture framework is nothing but the view that are abstraction. So mainly this can be done with the help of UML. UML is nothing but Unified Modeling Language. Okay, Unified Modeling Language is mainly used to define the different types of models in the design set, or can call as the architecture. Okay, so this will be mainly used to view the contents of the information and a relation between from one component to the another component. And next one is when we are designing the design model. So mainly we are going to check that what is the depth and width. So here we are going to check it what is the width and depth of the information during the building of the design. And also here while you are designing the architecture view, so mainly we are going to concentrate upon the abstraction of the design model and check the what is the significant information for the architecture. And also we need to verify. So while we are designing any system, mainly they are going to consider the four views. One is design view, next one is process view, component, and the last one is deployment. These are the four views are very important for the real world systems. So by using these four views only, they are going to check that the software architecture and constructions, and they can have the different types of the views here. So what is the use of design view? So design view is mainly used for the checking the structure and functionalities of the design model. So what is the structure, how the structure will be there, overall structure of the software architecture, and how the functionality between the from one component to the other component, and also the process. The process is very important. So we know that the process can be is we can have the one application. So application we can call as the process. Okay. So the process can be have the concurrency. So there we can have the multiple process can be run at a time and check the different types of the threads. Okay, and we can have the relation between the this process and also used in the design component in the deployment use. And next one is component. So a component is nothing but the overall structure. So how the structure will be there, how we are going to deploy the different types of the components or the subsystems in the components. This can be mainly used for the implementation, how the components can be implemented or imported into the different types of the components. The next one is deployment. So deployment is nothing but so different types of the components has to be inbuilt in the components. So here these are the four views for construction of the any software architecture. Okay, so the design view is mainly used for any system, and also we can add the different types of the views. For example, if you are taking the any distributed system. So if you are considering any distributed system, so there we require the process view as well as the deployment view. Why means, so the information has to be allocated to all the information on the system. So the resources has to be shared to the all the resources. So there we require the concurrency of the process as well as the threads. So we need to control the threads as well as the process. And deployment view is nothing but the placing of all the components into the particular structure. And next one is when you're considering the large system, so there should be a mixture of custom as well as the commercial components. Why means, if you're, for example, if you're designing the small project, so there we require only the custom components. So custom components is enough. But when you're designing for the complex projects, so there we require the custom as well as the commercial components, because we need to require to check that the different types of the components we have. Okay, so here in this diagram we have the different types of the stages are there. The first one is the requirement. Okay, so requirement is there, design is there, implementation and the deployment. So requirement is nothing but the discussing about the problem. Okay, the problem, how we are going to discuss the problem here. Okay, so the requirements it maybe include the various types of the UML models, and they are going to discuss the problem space. Okay, that is about the requirement. So whereas the design, so in the design they are going to include all the UML design models, and they're going to find out the solutions for that problem space here. And next one is implementation. So implementation and deployment. Here implementation is nothing but how the components can be implemented. There we are going to use the source of the different types of the components. Deployment means we are going to give the demonstrations of what you are going to implement in the components. Okay, and next stage can call as the depending on the complexity. If the complexity is heavy, so there we need to divide the models or the partitions into a single module. So here it is divided into a use case model, design model, process model, component model, and deployment model. So here it is divided into the model is divided based upon the complexity. If it is a complexity of the model, then it is divided into a 5 types. Okay, so here the use case model, design and the process. We have the design, process, and the use case model. Maybe maximum we can use for the visualization. So then we can have the physical as well as the logical. So this can be mainly used for developing the visualizations of the logical, and we are going to check that behavior. So how the relationship between from one component to the another component. And next one is component model is mainly used for the visualizations of how we are going to implement the subsystems. And deployment is mainly used to how the various components has to be deployed in the architecture. So this also called, so mainly the UML is mainly used for the visualizations of the abstract models. And the next stage, so here we have the architecture can be have the several views based upon that, and this can be use the design models and use the significant structures, collaborations, and the behavior. So we have the use case, design view, process view, component view, and the deployment view here. So these are based upon the complexity, and the architecture can be divided into a different types of the views. Okay, and also other than that, we can have the another views based upon the complexity in the engineering models. Okay, the requirement model, as we discussed, that mainly it will be addressing the problem space and how the behavior of the system can be seen. So this in the initial stage, mainly they're going to have the end user and analyst and the testers. These are going to discuss more about the problem statement of the project. And the next one is here. Here we have the views we can have in 2 types. One is static and another one is dynamic. Okay. So in the static, we may have use case and class diagram. Okay. So this is comes under the static one, whereas the dynamic sequence diagram, and next one is collaboration diagram and state chart, and the last one is called as the activity. So this will be used for the dynamic views. Okay, so it is divided into 2 types. One is static and another one is dynamic. In the static, use case, class, and objectives maybe they are going to use, and whereas the dynamic sequence, collaborations, and state charts and activity diagrams. So these are the various views will be there. Okay, and here the use case view we can mainly use for the how the relation between from the system, means from the actor to the system. So there we need to have the relation between from the actor to the system. Okay, so it will be describes how the system critical, and use cases are realized by the elements of the design model. So this is mainly used for the static purpose, whereas the dynamically is nothing but how the UML will be behavior based upon the diagrams. So in UML, mainly in old, we have the 9 diagrams are there. So later it changed to 11, and now as per the new, so it's UML diagrams is consisting of 40 diagrams. Okay, so sometimes the collaboration and collaborations can be used for the dynamic purpose. Okay, the design model. So in the design models, mainly it will be addressing what are the main issues in the components, and also they need to check the functional structures and concurrency, how they're going to implement the structures, and execution of the solution space here. Okay, and static descriptions is mainly used for the structural diagrams. So we know that structural or the static diagrams are such as class, object, component, and the deployment diagrams. So whereas the dynamic descriptions means UML behavior dynamically, we can call as the collaboration, sequence, state charts, and activity diagrams. So these are the 2 different types of the descriptions of the static as well as the dynamic. In the design view, So not only they're going to check that what are the main elements are there for the design model, and also they need to address the basic structure and also give the more in detail solutions for the functionality. So we have seen that static as well as the dynamic. Statically can be how the classic class and the object diagrams, whereas the dynamic, so it will be used for the how the UML will be behaving based upon the diagrams. The process view is mainly calculating the runtime collaboration issues. So we're going to check that what are the runtime collaboration issues will be considered during the execution of the architecture, and also they need to check that software network topology. So which type of the network topology they're going to implement. So whether it can be, so this process and the threads has to be controlled, and they need to use the various IBS, that is inter-process communications. So we know that inter-process communications such as pipes, named pipes, message queue, shared memory, semaphores, and sockets. So these are the main inter-process communication. This based upon the process how the information can be computed, whether it can be a sequence or a concurrency. So first two, so mainly it will be the static or the sequence. So even in the message queue also it will be using the sequence manner. So remaining thing it will be using the concurrency mode. So the views can be have the different types. So that is static as well as the dynamic. Okay. What is meant by component view? Component view is mainly used for how the architecture can be, different types of the elements can be implemented. Okay, so they can be how the design model addresses the software source realization of the system. Okay, and also how it can be projects based upon the integrators and the developers, and they need to check the different types of the release and configurations, and they need to check that statically component diagram is in the static form, and whereas the dynamic, so they based upon the behavior. Okay, so deployment is nothing but it is in the executable realization. It means they need to give the demonstrations, and the information has to be logically distributed from one view to the other view. This information has to be transmitted from the logical process to the physical resources. So based upon the whatever the topology they need to implement it. So here the static one we can call as the deployment, and the relation, like we have the association, aggregation, realizations and relations. Okay, how the it can be one to one, one to many to one, or many to many. Okay, and also the architecture description. So we have the different types of the forms, and it can be implemented in the different organizations and domains. Okay, the architecture can be based upon, so based upon the requirements, this can be changed. So how many components or the subcomponents has to be implemented in the engineering sets. So based upon the situation, so they may have some good heuristic. So it means the architecture can be different. So based upon the situation, they need to implement, they need to add some components or they need to eliminate some components. And also here, the components can be how the requirement. So we know that the requirement stage, so mainly they need to consider about the use case, critical use cases, or we can call it as the business use cases. Okay, why they require the critical use cases means they need to check that how much critical the project or the software architecture it is. Okay, in the initial stage only they need to discuss about the critical use cases, and also they need to check that what is the quality of the software architecture. So based on the objectives and the components they need to implement it. And next one is design. So in the design we know that so many we need to verify about the different types of the components and the behavior, and they need to use the names, attributes, structures, okay, and grouping based upon the classes and the components. And the implementation, so we know that implementation is mainly used for the coding part. So there they need to check for the inventory and the bill of the materials, like a name, number, the purpose, what is the cost, And the deployment. So deployment is nothing but the final one. So they need to demonstrate the critical use cases and what is the risk assessment will be there, whether the risk is high or low, and they need to verify the quality during the deployment. And these are the main technical details about the architecture. Okay, and they need to check that how much the success will be happen based upon the software architecture depends. Okay, so when they're designing the components very effectively, then the architecture development is crucial to success. If not, the architecture will be failed. So that's why for that they need to take all the constraints to get the to achieve the success. And also they need to check that what are the main challenges for the project manager. So they need to balance the all the elements, and also they need to success for the project. And so architecture baseline is nothing but they need to balance the subset of the information. So based upon the architecture description and within the design sets. So we know that the conventional approaches and the modern iterative development process. In the conventional approaches, the main difference is in the waterfall model, you can call it as the conventional approaches. So there, the criticality of the risk is very heavy because so they cannot identify the issues in a starting stage or the initial stage. So after completion of the project only, they are going to identify the so what are the issues or the criticality in the project. So then the cost and the schedule will be increased. So whereas in the modern iterative development process, so mainly they're going to check that having the inspections in each and every like quarterly, and the inspections will be happen. So the modern iterative process will be very efficient and the sufficient evidence to achieve the software architectures. Okay, in the conventional approaches, when you're taking this architecture baseline, so mainly they're going to based upon the documentation, sometimes they may not be provided, and the validity of the integrity also somewhat. Okay, so that's why the conventional approaches cannot be guaranteed that success rate when they're taking the complex or the large projects. So whereas the iterative development, so the architecture baseline is the partial. So they need to take all the tangible evidence. Okay, so they need to validate the architecture and take the different types of the requirements and execute the plans here. Okay, and also here the architecture description. So mainly they need to check the forms. We know that the UML diagrams having the from different types of the complexity to check that how the information can be compartmentalized and consist of the sophisticated systems. And also they need to check that what is the skill. Okay, the skilled person is very important while they're designing the software architecture or any product. So because the small or highly skilled team is very important to building the software architecture, and also they need to face what are the problems will be occurred like catastrophic cost of failure command and control systems. Okay, so this team when they're having the highly skilled team, okay, so they can easily cooperate with each other and they can try to minimize the problem. Okay, and the project life cycle. So we have the 4 phases: inception, engineering, and collaboration, and the transition. So the information can be starting from the requirement and the architecture, that is design antigraphs, and production stage. So we have the implementation and the deployment antigraphs. Okay, the transition we can call as the final stage, the production stage. So where they can be achieve the project successfully. Okay, so when they're considering the management perspective, so they need to agree, satisfy the stakeholders, because the stakeholders are given the problem statement and they need to achieve the vision of the stakeholders. And here they need to check that what is the implementations and highly predictable cost and schedules. So based upon the things, they need to give the demonstrations. So demonstration is very important in the modern iterative cycle. Okay, so the demonstrations provide far more tangible feedback. So when you're giving the better demonstrations to the stakeholders, so based upon that, the feedback will be given by the stakeholders. So solutions will be given, and more standard components are used. So here, while they're discussing about giving the demonstrations about software architecture, when they're implementing the standard components, it will be very simple to achieve state and implemented the good software architecture. So here, when they're not using, sufficient custom as well as the, commercial components, they may be, the cost will be double. Okay, the more custom components are, so when they're using the more custom components, so the harder it is to achieve. So that's why we need to concentrate about the custom as well as the commercial components to minimize the cost for the construction of the software architecture. Okay, so this is about the technical perspective for the software architecture. This is the reference. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.